Why can't a simple AI chain check its own work? That question is exactly what LangGraph answers. A chain is a straight line. Prompt, then LLM call, then output. Fixed order every time. But what if the model needs to check its own answer before it's done? A straight line can't loop back on itself. There's no way to send the output back for review. LangGraph solves this by modeling the whole process as a graph instead of a chain. The same 3 steps, prompt, LLM call, output, become nodes on a graph. Now they're connected by edges, not locked into one fixed path. Nodes and edges, not a fixed straight line. That's the flexibility a graph gives you that a chain never could. So what exactly is a node? Each node reads the state in and returns an update to it. A shared state object travels through the graph, growing as it goes. It starts with just one field, the question. A node adds a draft answer, so now there are 2 fields. Another node adds a score, bringing it to 3. A final node adds the final answer, bringing the total to 4 fields. That growing state is what every node in the graph is reading from and writing to. Now here's the part that makes agents possible. Conditional edges check the state and they can loop back. Picture 2 nodes, generate and check. Generate produces an answer, check scores it. If the score isn't good enough, the edge routes back to generate to try again. If it passes, the edge routes forward to done. How does this actually get built? It's defined explicitly in code. You add a node for generate, add a node for check, and add a conditional edge that calls a routing function to decide where to go next. Once the graph is defined, you compile it into an app with graph.compile. Then app.invokeOfState runs the whole thing, starting from the entry node and following the graph until it's done. Why does this matter for agents? Because this is exactly the think, act, observe loop made explicit as a graph. An agent thinks, takes an action, observes the result, and decides whether to loop or move on. That's precisely what conditional edges give you. And as a bonus, nodes can also branch into parallel paths that merge back together, something a simple chain could never do. LangGraph means agents as graphs, not just chains.